No.
Now you see the slide full screen.
Yeah. Yes. Yes. And then you and I are on the top.
So here I was talking about the PMMA bridge uh, that can be either milled or printed. And I was mentioning the fact that this, if it's not reinforced, it's very weak because it does not provide a good splint to the underlying implant. Those are the numbers that I was commenting on. So
Oh,
basically, it shows that
right. Yeah.
PMMA
I've seen those numbers.
very soft,
I,
very
I
flexible.
noticed. I noticed that the 920 MPa on the resistance compression looks. Oh, this is Zantex too. Okay, I see.
Yes, yeah, it's
Okay.
huge.
Yeah, I think
It's
it's a little
huge.
higher. Yeah.
And this is compared to Chrome Cobalt. So Zantex is even stronger than Chrome Cobalt for all that matter. And flexion, Zantex is even better than Chrome Cobalt. So before we were using cast metal to reinforce those bridges, now we can do it very easily with Zantex.
Right.
And some people are using Pecton or Peak. The companies marketing that are spending millions of dollars to try to get that to market. But if you look at those hard number, the numbers don't lie. This shows why those guys are not the best materials to do this job because traction is around 100 megapascal. Flexion at 200 is better than PMMA, but it's not very good. The modulus of elasticity is the same as PMMA. And compression, even if it's better than PMMA, it's far from Zantex. So, and this is your zirconia, you have them all here.
Right.
So, what we are trying to do, we offer a 100% digital way to upgrade the PMMA bridge and making it virtually unbreakable, but we keep the aesthetic because what we'll do, we will modify this PMMA bridge on the right, you see, creating a slot before being printed. And then we will have the counterpart positive milled from a Zantex arch in order to achieve this. So when you put the two together, that's what you get.
You superimpose the images.
No, it's not superimposed. You just slide the drawer in the slot.
Hmm.
Okay. And this, and you can even cover the lingual part with acrylic. So it will be all the same color and all the same consistency. Okay. So of course, the numbers that I have shown you, they are proven, they have been done and submitted to the FDA, and they have been done according to standards. So they don't come out of the blue. Okay. And also the material is biocompatible. All those ISO testing has been done by independent labs and submitted to the FDA as well. Now, I have shown this data that has been published in June 2021, showing the structure of the Zantex. Basically, it's fibers, three-dimensional network into a biocompatible polymer. And on this fatigue study, it shows that when the structure breaks, only the composite breaks, so it's easily repairable. The Zantex does
Yeah.
not even get scratched. Okay, so the idea that we are showing here, it's how to improve the lab productivity and reduce the cost. instead of milling the Zantex from a full disc, we will just milling from this pre-form, this pre-shape. So the milling time is going to be divided by 3 or 4. So we created this holder, which is a fake 98 millimeter disc.
Do you have it in? Do you have it in 95? Is what my customer wants. That works with Heart.
That works for which machine? The Zirconzan?
Yeah, I think I asked you about it in the past. We have 98. I think he has 95 or 96.
Okay, we can make this dummy disc very easily according to his specs, very easy. So that way he will be able to machine the arch. That's very simple.
Okay, good.
We just need to design it, and we can even give you the STL file, and he can print it. If he does, he have a 3D printer to print models and stuff like that?
That's a good question. I mean, I could ask him. I'm not so
Yeah,
sure.
they probably have many labs now. They don't
Well,
use.
he's not allowed.
So, what would be good is that, it's for him to show this procedure. So what we offered, I say, it's a procedure that is 100% machine. So there is very little labor, human labor, and mostly machines working, which is, what everybody dreams about.
Right.
So the way it works, the previous design that I show you is going to be exported into a STL editing software. Here I use Fusion 360. You can use Mesh Mixer. Those are free software, so it's it's very simple. So the way it works, you import the bridge, you import the arch, and you position it in an ideal way.
Right.
And when you are happy with what you did, you see this is the intersection of those two structures. You see the bridge and the blue arch. The intersection creates this. All right.
Right.
Now from this, you are going to create a virtual cutting tool. Here it is. And you just position it onto the bridge and use the cut function, and it will give you this. And this is the modified bridge. So the lab will not print the full bridge version, but the lab will print this version. Does that make sense?
It does.
And then you will have the counterpart of the Zantex arch. You can see in 3D how it looks like.
Mm-hmm.
And you will just slide this into the slot. And bingo.
Wow.
And you can manage clearance. Here I've put like a 0.2 millimeter clearance. So you can really slide it easily. What you do with a brush, you just brush some PMMA inside the slot. You slide this. And then here, can you see my mouse? Can you see the mouse?
No.
No. What about if I do this? Can you see the mouse?
I see it. Yeah, I see it.
Okay. So what you will see here in those holes, you will put the titanium cylinders. Actually this way, they will go from this way, and the whole thing will be totally locked in. And then it will go nowhere, and you will have an upgraded PMMA bridge with still the look of PMMA, but
Wow.
the resistance of chrome cobalt,
Wow.
which
I like
is
that.
unbelievable.
Yeah, that's
It's
awesome.
done.